In the continuation of our online EDA tool, we will be taking you through. So I am Ravikant Khamitkar, working as an assistant professor in Department of Electronics and Computer Engineering, Walchand Institute of Technology, Solapur. Now, we have seen in the previous session that the ultrasonic sensor can be interfaced. Now, how the ultrasonic sensors, whatever sensed value, can be considered for an actuation, like action to be taken. So we will check out how that actuation action can be taken. So at the end of this particular session, what we will be utilizing is, we already understood about interfacing of ultrasonic sensor in the previous session. In this particular session, we will be considering the interfacing of the relay. So how the relay can be used. So let's jump into it. We'll click on it. So we'll tinker this. Now here, this particular transistor, now this is connected to the relay part. Now if you see this particular relay, this is the coil, this is one, and this is the other terminal of the coil, you can see in here. This is normally closed connection, this is normally open connection, this is terminal 1 and this is terminal 2, which are short. Actually this is like common terminal. Now common terminal is connected to the normally closed, but whenever this coil gets energized, which is connected between these two terminals, what happens is this particular the switching action happens, and this is normally open, which is gets closed when this particular coil gets energized. This is the principle of working of your relay. Now here, transistor based driving circuit, actually what happens is your microcontroller cannot drive directly the relay, because the amount of current required to energize this is not able to handled by the pins of the microcontroller. So this transistor based switching action is utilized, where the base is provided from this pin number 4, the base is connected, where it connects this particular base of the transistor, which acts as a switch. So this is the ground pin, which is the emitter connected to the ground. To the collector, the coil, one part of the coil is connected, and the energy is from external 6 volts supply is connected to this particular other side of the coil. So this gets energy from it. The ground of this particular supply is made common with your Arduino board, and the other side, like this is the common terminal and this is normally open terminal, is connected to this particular driving circuit of your LED. So what happens is, whenever this particular circuit gets completed by charging this particular energizing this coil, so this circuit gets completed and this LED will be turned on. This is the simple coin based supply. Battery is provided. This is the current limiting resistor connected to the anode of this particular LED. This LED gets energized whenever we will be providing the supply to this pin number 4. So pin number 4 energizes this particular transistor. Transistor acts as a switch. This provides the path from this particular supply through this coil to the ground, and which indeed energizes this coil, which switches, this electromechanical switch turns on, and the common terminal gets connected to the normally open terminal, and this circuit completes and this LED will be turned on. Now for this particular circuit, we have connected very simple program. We have written very simple program where every 5 seconds it will be turned on and it will be turned off. So for first 5 seconds it will be turned on, later after 5 seconds it will be turned off. So we'll see that, like very simple program. If I start the simulation, you can see that this particular LED is turned on, and after 5 seconds, you can see here time also, and after 5 seconds this again, like this LED, there is an animation of this, like you can see that it is on, now it is turned off. After again 5 seconds, this particular, now this is turned on again. So we can see that with this, you can see that the LED is turned on again, and this is animated. Now I will stop the simulation simply. So what I can do is, we'll take this, take the help of your ultrasonic sensor. So we'll copy that code also. I will show you how simply we can combine these together. So we'll click on this ultrasonic sensor, and together using the ultrasonic sensor, how we can achieve both, like using this, we can tinker that. So in case of ultrasonic sensor, if the distance reduces below, say below than 100 centimeters, like this LED should turn on. So what we have connected in here. So for that sake, what we'll do is we'll try to take the help of this particular code where it is already, we have the part of eco and the other pins. So we'll use this, right? And then apart from that, what we have is in setup. So ultrasonic sensor, trigger, and the eco pin. So we'll set that up similarly. So pin number, it should be pin number 4 that we are using, the like trigger and eco pins. And now what we can do is, on the basis of what we are getting, we'll be triggering that. So before taking it up, and based on the values that we are getting, so if the value of distance is less than 100, then and then only what should happen is your relay should be turned on. Otherwise, else this should keep this particular, else it should keep this particular. So we don't need delay now. We'll remove this delay. It's simply what it does is, if we have this particular thing, if it is, the distance is less than 100, it will turn on the LED, and if it is not, it will. So to add with, now we have changed the program part. Simply what we'll do is we'll connect this particular ultrasonic sensor. So ultrasonic sensor will, you can see that it is 4 pin, we need to connect it. So from the program we can see that the trigger pin, this trigger pin is connected to pin number 10. So we'll connect this trigger pin to pin number 10. We'll change the color to pin number, like we'll connect it to pin number 10. This is eco pin, which is connected to pin number 9, and this is your ground pin. We are going to connect it to ground, and the last one is your VCC. This is like 5 volt that we will be connecting it to. Now basically what happens is, when we will start this particular simulation, we'll be able to see this LED is turned off. That means like this is like 113 centimeter. Now if I reduce it further, you can see that the LED has turned on, means ultrasonic sensor giving the distance. So if I go back and see the distance, which should be like less than 100, and that's less than 100 is providing me with the connection, like it's greater than. Now if I further again changes the distance to 181 centimeters, now you can see that the LED has turned off. So what do you mean by this is it is a simple the sensor and the actuator action together that we can see on the screen with the help of ultrasonic sensor. What are the possible applications with this? Like, so there are a number of applications that you can build using this particular ultrasonic sensor. And now to name the few, like the smart dustbin is one that you can prepare it on. Even like in case of theft alarm, uh, we can connect it the ultrasonic sensor, and if some object or obstacle comes in front of it, it turns on that light in front of your gate. Or even like if you are traveling through this, like, and you wish to open your gate automatically whenever the your own vehicle comes in near to the gate, then also it is possible that even like the sort of touchless doorbell is another application that you can build upon. So these are like various application that you can build upon. So you can always go through the code, you can check out what are the variables or what are the computations we had done, and you can implement this. So with this we'll stop the simulation for this particular thing. Thank you so much for your patience and listening to this particular session. We'll meet you in next session. Thank you so much.